Schematics are important. A schematic diagram is a diagram that shows you what the circuit is supposed to look like, how things are connected, how they will be connected in the real device. So it shows how they're going to be connected, and you generally, you need to understand schematics. So on the one hand, you need to be able to build a circuit given a schematic. So if somebody gives you a schematic, you need to be able to wire things accordingly. I do that all the time. You know, you find a circuit diagram for something that you want to implement, and you implement that. You just say, okay, let me wire the circuit based on this schematic. So you need to be able to do that. So you need to be able to read it and understand it and be able to wire it together accordingly. Also, even if you're not taking somebody else's schematic, you have to be able to draw your own schematic. So say you're making a new device, you put together in your head how things should be connected. You need to be able to write that down in the form of a schematic. So you need to be able to take your design ideas, draw a schematic appropriately that sort of matches the connections that you think are necessary. So schematics are important. Now schematics, once you have a schematic, you eventually have to wire that schematic up. You have to take that schematic, which is a symbolic representation of the circuit, and you have to make it a real circuit. So you have to wire up the components according to the schematic. Now we're going to do that in this class, and we're going to use, for wiring, we're going to use a solderless breadboard. Now, basically, what are we using a breadboard for? The idea is that when you're wiring things up, wiring together a circuit, you have to connect wires together. So say I want one resistor connected to another resistor. I got to take one wire, one resistor, the other wire, the other resistor, and connect them together. And we're going to use this solderless breadboard for that purpose. Now, another way to go about this, which we will not cover in this class, but another way to go about it is to do soldering. Soldering is where you take the two wires that you want to connect, you put them together, right, and there's a joint. Then you take a hot iron, okay? You heat the joint. So you put the hot iron to the joint to heat it up. Then you take a piece of solder. Solder is a metal, a soft metal with a relatively low melting point. And you take that solder and you touch it to the joint. That solder melts, and you pull away the solder, but you get a little glob of solder on the joint that's melted and is now connecting the two pieces of wire. Okay? That's soldering. We will not do soldering in this class. Soldering is a more permanent way of doing things, right? So it's a much more secure bond. And it's good. It has good physical strength, also good conductivity. Soldering is very good, but it's a permanent thing. Or I shouldn't say permanent. You can undo soldering, but it's more of a hassle. A solderless breadboard is much easier because you can just take the wire, stick them in a hole, pull it out the hole. Okay? Easy to redo things. Is great for prototyping, which is what we're doing here. So solderless breadboards, they allow components to be easily connected in a non-permanent way. Great for prototyping, what we're doing. So there are holes. If you look at the board, it's got a bunch of holes. The holes fit 24 American wire gauge solid wire. Okay, so gauge, American wire gauge is a thickness, is a measure of the thickness of the wire, right? 24 gauge is what comes in your kit, okay, and it's a standard thickness of wire. And those wire thicknesses, solid wire, not like the stranded one that's all braided, but a solid piece of wire. If you get solid wire, it'll go right into that hole and fit. So that's what they're made for. So the breadboard, there are holes in this breadboard, and some of these holes are connected to each other. So they're connected, generally, if you look at the central columns of this breadboard, you got rows of 5 holes, right? And you can see I put these green lines over rows of 5 holes. So every row of 5 holes is connected. That means if you stick a wire into one hole in that row of 5 and another wire into another row of that hole of 5, those two wires are connected. So that's how you connect two components. You stick one end in one hole in a row of 5, stick another end of another component in the same row, and then they are connected. Now notice that in addition to these rows of 5, you got rows of 5 on the left, rows of 5 on the right. There are these columns on the sides, right? These long columns. Actually, they're grouped in 5s, but basically they are long columns. And you can see I've highlighted them in green too, these vertical columns. So those vertical columns are connected differently. They're not connected in groups of 5. The entire column is connected. So in this breadboard that you see here, there's 2 columns down the left, 2 columns down the right. Each column, all the holes in one column are connected, okay, in each one of these 4 columns on the sides. Now, those columns are generally meant for power and ground. So you usually put power on one side, ground on the other. In fact, in these breadboards, they commonly use red to represent power and blue to represent ground, although I like black. But that's the color they use. The color doesn't really matter at all. You can wire whatever into whatever. But it's supposed to be used for power and ground. And the idea here is that when you've got a breadboard, say you've got a long breadboard, big circuits you want to wire together, you've got lots of components on there, maybe lots of integrated circuits, chips, things like that. Most of these components, or a lot of these components, need power and need ground. Okay? It's very common that all your components will need power and ground. So you want power and ground to be wired to lots of different components, and rather than run lots of wires, they just say, look, take power and ground, put them in these columns, and then you can just feed short wires. Since the columns run up and down the whole breadboard, you can just run short wires from your component to the column, to anywhere in the column. So that's what the columns are for. Now, you can use the columns for whatever you want. You don't have to use them for power and ground, although everybody does, so you should, but you don't have to. Physically, they are just connected. The entire column is connected to each other, so you can use them how you want to. But this is what we're going to be using for wiring, generally. So, the process of wiring our circuits. Now, I just wrote up a sort of a simple process for wiring devices, which fits most of the time. So first, so say you've got, and this wiring process means, I'm assuming you have a schematic, and you are now trying to wire a circuit together according to this schematic. So this schematic, it's got several components, several hardware components in it. So you select a hardware component that you want to wire. Then you select one of the terminals on the hardware component. And this hardware component can have several terminals. If it's a resistor, say, it's got two terminals, two wires coming out of it, right? So you select one. And then you put it into the board. You connect the terminal to a row of the breadboard. Now, which row should you connect it to? Well, that depends. If this, say it's a resistor, right? And we just put one end of the resistor into, we're going to put it into a row. If that terminal needs to be connected to another terminal on some other component that is already in the board, then we don't have a choice about what row. We just say, look, it's got to go into row X because row X is connected to the diode that I want to connect to. Right? So if you already have something in the board that you have to connect this device to, then you just put the terminal into that row and just share the same row. But if this resistor that we're putting in isn't connected to anything that's already in the board, then you could just use any free row. Any row that's available, you just use that. Okay, so you've put now one terminal of this resistor, let's say, into the board. Now go back to step 2 and select the other terminal on the hardware component. So this resistor has got another terminal, so you do the same thing. You put it into another row of the breadboard. And again, it can be a free row if it doesn't need to be connected to anything, or it has to be, or it can be a row, the row of, the component that you're connecting it to. Either way. So then you just do that until you've wired up all the terminals of your hardware component, and then you just go to the next component. You start again with a new hardware component, and you do that. And that's your process, and you keep doing that until you've plugged in every hardware component. Thank you.